The midpoint of a segment is the point that divides a segment into two congruent segments, two segments that are the same length. In the image here, M is the midpoint of segment AB. Notice the hash marks. That means those two segments are exactly the same because the midpoint cuts it in half. So segment AM is congruent to segment MB, and the length of AM is equal to the length of MB. I'm going to put this into terms of something we all know and love, food. Okay, we got an 8-inch sub sandwich. It's lunchtime and I'm hungry. Okay, the midpoint of that sandwich is if we were to cut it right in half. So 8-inch sandwich right in half, the midpoint would be right at 4. A segment bisector is a point, ray, line, line segment, or plane that intersects the segment at its midpoint. A midpoint or a segment bisector bisects the segment. Key word here, bisect means to cut in half. In the image to the right, segment AB is cut in half at point M by line CD. Just a reminder, segment bisectors can be points, line, line segment, ray, or plane. And here is a quick little cheat sheet of what those are. A segment can be bisected or cut in half by a point, a line, a ray, a segment, or even a plane. Going to do some problems here. First example, section 1.3, exercise number 1, identify the segment bisector of segment PQ. We have segment PQ here. The segment bisector is what cuts it in half. Notice it is cut in half right here. What is cutting in half? What is a ray? Starts at M and goes through N. So which one is this? It is ray MN. Okay, we also want to find PQ. There's no line over the top because it's wanting to know the actual length of PQ. So the length of PQ, we are going to notice here, this bisector cuts it right in half. It's the midpoint. And so these two segments are congruent. That means this segment from here to here is also 1 7/8. So we're going to add those together. 1 7/8 plus 1 7/8. Little fraction work here. Honestly, I run from fractions too. 1 plus 1 is 2. 7/8 is 14/8. So we have 2 and 14/8 from here. Get your calculator out. 2 plus 14/8. 14/8 is improper, so we're going to divide that in. 8 goes into 14 one time. What's remainder would be 6. So 1 6/8. So we're going to add those together, and we have 3 6/8. One more step. I know it's probably been a while. Use your calculator. It's totally fine. It would be 3 3/4. Gosh, yeah, 3 3/4. There's your answer for that one. It was super fun. Hopefully this one's not as bad. All right, identify the segment bisector of RS. So we have segment R to S here. It is bisected right here, cut in half. What is cutting in half? It's a line. All right, so let's see which one's naming this correctly. This line doesn't have 2 points. Okay, so there's no way to actually name it, except for it does have this N here. Remember, you can name a line by 2 points or a letter naming that line. So this is called line N. These segments are congruent because it is bisected. So that means that this length is going to be the exact same as this length. So when they're the same, we can set them equal. Good. We got to do fractions, and now we get to do algebra. 4x plus 3 equals 6x minus 12. All right. You guys remember this stuff? Starting off strong here. We are going to subtract both sides by 4x to get rid of this here to combine our terms. So subtract 4x. I am then going to have 3 equals 2x minus 12. I'm going to add 12 to both sides. So we have 15 equals 2x. Divide by 2. And we can leave that as 15 halves. You can put that in your calculator, or we can reduce that fraction into 2 goes into 15 7 times. Left over 1, 7, and 1/2. If you're having struggles with this algebra part when you solve these equations, this is geometry, but there is algebra in geometry. So at this moment right here, if you're like, wait, I don't remember the algebra part, please reach out to your teacher so we can set you up with a plan of action. Let's start by talking about average. What is average? Average is the middle. Okay, you take all your data, add it up, divide it by the number of input values, and you get your average. Same thing when we're talking about midpoint. Midpoint is the average of 2 points. It's the middle. Okay, let's go back even more and talk about what a point is. So recall that a point is a location on a coordinate plane. A point has an X and a Y location. Let's plot our first point. We're going to call it X1, Y1. First point. That point is at -2, 2. -2 in the X direction, +2 in the Y direction. Our second point, X2, Y2, that just means your second point, is at 1, -2. 1 in the X direction, Y, or -2 in the Y direction. If we were to want to find the midpoint of these 2 points, it's going to be somewhere right in the middle. We can guess where it's at, draw a line, find the middle, or we can use the midpoint formula. The coordinates of the midpoint of a segment are the averages of the x coordinates and of the y coordinates of the endpoints. So midpoint formula, you add your x coordinates, divide by 2, add your y coordinates, divide by 2, and you have your midpoint. Take a second and click on that link below, the midpoint formula, and it'll open up a GeoGebra applet, and you can play around with it for a little bit. Fiddle with it, put some points places, and it might even help you on some questions on your quiz. Next set of problems using that midpoint formula, 1.3 exercise number 6. The endpoints of A, B are 1, 2. So let's go ahead and plot that point, 1, 2. 1, 2 right here. That is my point A. And B, 7, 8. 1, 2, 3, 4. Oh gosh, we have to continue this out, don't we? 7, 8. That's way up here too. Let's just continue this up. 1, 2, 3, 4, 5, 6, 7. Super accurate. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8 right here. Okay, that is point B. And we're going to try to find that midpoint. So again, the midpoint is if you were to connect those, where would be the middle? We can kind of make a guess, but let's not make a guess. Let's use the actual formula. So the formula, just a reminder here, if we scroll up, you got it right there. Look at that. It's right there. You plug in your x values and find the difference. So midpoint is equal to the sum of our x values. So our first x is 1. Our second x is 7. Divide that by 2. And our next coordinate are some of our y's, 2 plus 8. This is nice. These are even, like it when they turn out even, divided by 2. And so our midpoint is going to be at 7 plus 1 is 8. 8 divided by 2 is 4. And 2 plus 8 is 10. 10 divided by 2 is 5. Our midpoint should be at 0.45. 1, 2, 3, 4. 1, 2, 3, 4, 5. We are pretty close right there with our guesstimate. Next problem, a little bit harder here. The midpoint and one endpoint are given. This time we're given the midpoint. We're trying to find the other point. Let's see if we can do this by graphing. So our point is, for t is 1, 1. So let's go ahead and graph that point. 1, 1, that's t. The m is your midpoint, 2, 4. 1, 2, 1, 2, 3, 4. That is m. And what would the other coordinate be? So think about this for a second. We want t. Oh, that is a fat pen. I do not like that pen. We want t through m. Where is the other point going to be? Where m would be the midpoint of those 2 points. Where would this point u be? And we can guess here. We can actually do a little bit of slope and a little bit of counting, or you can plug it in using algebra. And so while you're trying to find that point there, maybe by getting yourself some more graph paper, extending it a little bit out, you can kind of see where that's going to be. But for the math of that algebra, we're going to use our midpoint formula. So midpoint, again, equals the sum of your x values. So x1 plus x2 divided by 2. And then your sum of your y values, y1 plus y2 divided by 2. And I'm just going to write over the top of these what we have. So we know our midpoint is 2, 4. And actually, no, I'm just going to do it in a different color and below it. So we know our midpoint is 2, 4. Okay, that's going to equal. We have one x coordinate. So this is our x1 and our y1. Plug that in. So we know our one x coordinate is 1. We don't know our second x coordinate, so I'm going to call that x2 and divided by 2. Oops, not quite ready to close my parenthesis. We know our y1 is 1 also, and we don't know our y2. Okay, these two things are equal to each other. So this is our x coordinate. This is our x coordinate of our midpoint. So we're going to set those equal. I'm going to use some more space over here. So we're going to say 2 is equal to r1 plus x2 over 2. To solve that, multiply both sides by 2. We get 4 equals 1 plus x2. You guys don't love the algebra part, right? Use graphing. Minus the 1, minus the 1. So 3 is our x2, our second x coordinate. Okay, let's move on here now and find our y. You're probably asking yourself why right now. The 4 is our y coordinate. So 4 is going to equal 1 plus y2 over 2. Multiply both sides by 2, just like what we did here. So then we have 8 equals 1 plus y2. Subtract the 1, and y2 is 7. So that means our coordinate is going to be, I'm going to use the big fat pen, it's going to be at 3, 7. And let's just double check. Wow, that is a really fat pen. I can't make it like much smaller. There we go, that's better. Our coordinate of our x was 3, coordinate of the y was 7. If we plotted that point, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Look at that. You guys could have just done it. Wait, you probably already had the answer, right? Because you could have done it way back then. Let's talk about distance for a second. What is distance? Distance is the length between a starting point and an end point, just like a race. The 100-meter dash, the distance of it is 100 meters. But how do we find the distance between 2 points, especially if we don't have any way to measure it? But actually we do, because it is a coordinate plane, and each space in between each hash mark represents a unit of 1. So if your points are horizontal, you can count the distance by counting the number of squares in between. if the points are vertical? You can do the same. But what if the points are diagonal? How do we count the number of squares? You can't. So you need to use what's called the distance formula. You're going to use the distance formula to find the distance between 2 points. This is derived from the Pythagorean theorem. Distance equals the difference of your two x values, so the difference of the horizontal values squared, plus the difference of the y values squared, and take the square root of your final answer. And be sure to play around with that link below, the distance formula, because it also might help when you get to a quiz. Our last problem, section 1.3, exercise number 10. I'm going to zoom in on that to make it a little bigger here. Notice I did put in a northeast southwest compass and our distance formula, so we can use that. Your school is 4 miles east and 1 mile south of your apartment. A park is 3 miles east and 4 miles south of your apartment. Estimate the distance between the park and your school, round to the nearest tenth if necessary. So we're going to go ahead and use our coordinate plane here, and we are going to likely use the distance formula. I'm going to notate that our apartment is here at the origin, so right in the center. So the school is 4 miles to the east and 1 mile south. So we're going to go 4 miles east, 1, 2, 3, 4, and 1 mile south. And actually, I'm going to change my color so you can see that better. And that point right there, 4 miles east and 1 mile south, is going to be the school. That point location is at 4, -1. Next up, a park is 3 miles east and 4 miles south. So park is 3 miles to the east, 1, 2, 3, and 4 miles to the south, 1, 2, 3, 4. That's going to be our park. So that point is going to be at 1, 2, 3, -4. So 3, -4. We connect those points. That's where we want to find the distance between those 2 points. So that is not a vertical or horizontal distance. And so we are going to need to use the distance formula. And so when we do that, we're going to plug our numbers in. For the x1, y1, x2, y2, it doesn't matter which point you label it, just to keep it together. So the 4, -1, we'll just call that our first point. So that's our x1, y1, first point. And 3, -4 would be our x2, y2. It's our second point. And let's go ahead and plug those into the distance formula. So distance equals the square root of, so it's x2 minus x1. So our x2 is 3 minus our x1, 4. Square that. Plus y2 minus y1. So -4 minus -1. Simplify this out. Make sure you work inside the parentheses first. So distance equals 3 minus 4 is -1. -4 minus -1. If you need to add the opposite here, helps me out. -4 plus 1 would be -3. Square that. Okay, now we want to square those numbers. Notice I kept the parentheses. That's on purpose because when we square everything in the parentheses, you're squaring the negative also. So distance is going to equal the square root of -1 squared. -1 times -1 is 1. Plus -3 squared. -3 times -3 is 9. So our distance is going to equal the square root of 10. You can leave it as this answer. That's actually more accurate, square root of 10 miles, but it does want, it says in the nearest tenth. So we're going to plug that in our calculator. Distance equals square root of 10. Oops, let's undo that. Square root of 10, plug that into desmos. 3.16, or nearest tenth, 3.2. Don't forget, you have a textbook in this class. It's called Big Ideas Math. If you click on that tab, then you can go to that dynamic classroom. You can do examples, complete self-assessments, all sorts of things, all sorts of more videos, and everything. If you're ever having troubles, you can definitely check that out and reach out for help if you ever need it.